Hey guys, in this VRChat avatar tutorial, I'm going to show you exactly how to build a fully functional tessellated 3D minimap using custom shaders and real-time render textures. This method gives you a dynamic height-based holographic minimap that reacts to your avatar's environment in real time. Before we jump into the setup and the coding process, let's quickly break down what tessellation actually is for anyone new to this term. Simply put, tessellation adds extra geometric detail and subdivision to mesh surfaces. For this minimap specifically, tessellation works alongside the height map data to deform the minimap mesh, creating realistic 3D elevation variations instead of a flat 2D map. That's what gives our final result that true holographic layered 3D look. Now that you understand the core concept of tessellation, let's start the actual tutorial with our base avatar hierarchy setup. First, create an empty game object on your avatar. This object will act as our fixed origin anchor point, bound directly to your avatar's root origin location. This anchor requires no positional or rotational constraints. It stays fixed to your avatar's core transform, which keeps our entire minimap system stable and consistent, no matter how your avatar moves or rotates in the world. Next, parent two cameras underneath the empty game object. Name them simply Camera and Depth Camera. Position both cameras at your preferred y-axis height, then rotate them to face straight downwards towards your avatar's feet or ground plane. I highly recommend using perspective cameras for both. Perspective projection is critical here, as it properly captures depth distance data needed for our height map calculations, which orthographic cameras cannot replicate accurately. Then, create a standard plane game object in your scene. This single-sided flat plane will serve as our physical minimap display surface. Position this plane wherever you want your holographic minimap to render on your avatar, and keep it as clean as a single-face render target. Now, head into your Unity project's assets folder to create our two render textures for real-time capture. Create two new random textures and name them Minimap and Depth Texture. Assign the minimap render texture to your main minimap camera, and assign the depth texture render texture exclusively to your depth camera. This separates our color visual data and depth distance data into two isolated streams for later shader processing. After setting up your render textures, create new custom materials, minimap material and virtual height map material. We will pair these materials with our custom shader later in the tutorial. Next up is the custom shader coding portion of this build. Create two new standard Unity shader files in your project, minimap.shader and virtualheightmap.shader. These two shaders will handle all of our minimap rendering logic, tessellation mesh deformation, and virtual height map depth conversion. Next off, I'm going to show you how the code is written for the shaders. They'll be displayed on the screen for you to copy and pause and copy. Once you finish writing and setting up both shader scripts, we'll hook everything up to our materials. Assign your custom minimap shader to the minimap material you created earlier. Inside the material inspector, populate the two texture inputs slot correctly. Slot 1, your minimap color render texture. Slot 2, your depth render texture. At this stage, you now have separate functional real-time color and depth texture feeds ready to drive our minimap visuals. The only remaining problem, default depth texture output does not contain proper height map contrast. Standard depth camera output renders flat tonal values with no distinct black or white evolution difference, which means we cannot use it directly for tessellation height displacement. To fix this, we need to build a custom virtual height map workaround system. Well, there are two common methods to create a usable real-time height map for the system. The first method uses a real-time scene lighting to simulate height map data, but this approach is extremely inefficient, frame drops, and inconsistent results in VRChat. We're skipping that method entirely. Instead, I'm showing you the stable, optimized workaround method that works flawlessly for VRChat avatars. Start by spawning a second plane game object. Align this plane to match the exact XY position of your depth camera. Adjust your scene layer in order to create a top-down sandwich structure. The first layer will be your depth camera, slightly higher than the second plane game object. Then is your plane object, lower than the depth camera. Then it's your minimap camera, lower than the secondary plane. This creates a clean capture volume, depth camera, second plane, and minimap camera. Apply your virtual height map material to this newly created capture plane. Once your custom virtual height map shader is applied to the capture plane, you'll see the system activate immediately. This capture plane acts like a transparent glass overlay, functioning similarly to the soft particles or volumetric fog systems. But the custom chunked depth sampling, the shader reads a real-time depth distance. Objects closest to the camera render bright white, objects further away render dark black. This dynamic contrast automatically generates a stable real-time virtual height map we can feed directly into our minimap tessellation system. With the virtual height map fully functional, our minimap core build is nearly complete. All of our 3D deformations come from the minimap shaders, tessellation settings. You can freely adjust the tessellation rate parameters. Lowering the tessellation means a higher mesh triangulation, finer 3D detail. A higher tessellation means a lower triangulation with not that much of a detailed plane. This depends on your graphics, depends on the setup of your PC. It's really graphic heavy. A critical quality note: both your minimap and depth render textures must be set to resolution 1K or higher, which is 1024px or higher. This ensures smooth, stable depth sampling and crisp minimap visuals. You can lower the resolution for low-end PC performance if needed, but 1K plus is recommended for best results. Keep in mind, your render texture resolutions values are stored in your project's assets folder. These settings cannot be adjusted in real time via VRChat avatar radial puppets by default. Your base tessellated 3D holographic minimap is now fully working. For extra customization, you can add custom radial puppets to control your avatar, like one for minimap render range, or minimap scale or size, or also the minimap tessellation height strength. The height deformation intensity is controlled by the shader's displacement strength parameter. This is what makes your minimap raise or fall to match the world terrain elevation. Well, that's the complete build process for our custom real-time tessellated 3D holographic minimap for your VRChat avatar. If you followed along the whole tutorial but still stuck on the shader code or the setup logic, I fully uploaded a working source code to Github. The link is pinned in the video description below, so you can reference or download the complete project files. Thank you guys for watching, enjoy your new 3D advanced avatar features, and I'll see you guys in the next tutorial. Peace out, buddy.